So the first new variable we're going to look at adding to our columns here. And remember, these columns, we call them the matrix X. Right? We'll use that later in our code as well. The first new column that we want to add is actually the age of the passenger. For most passengers, this looks really good. We've got numbers here, but then we already see here is one passenger, and that passenger does not have the age indicated here. The age is unknown. So there's a few ways of handling that, and we'll discuss them soon. What we will demonstrate now is how to simply compute the average age, and that's the average of the entire column age without the missing values, and just putting that value here as a token value. The advantage of that is that we can keep the other information in that column. We don't have to discard the entire column this way. Now we're going to use a library called Numpy, and Numpy really makes very efficient computations on all your matrix and vector style objects. So we're going to load Numpy and store the entire library in an object that we call NP. And that's what people typically do when they have NumPy. They call it NP. When they have pandas, they call it PD, because these are really, really popular libraries. People tend to be lazy and want to have it short here. With NumPy, it's really easy and, as I said, very compute efficient to calculate that average age, right? But if we would do it straight away, there would be an issue because some of these columns, they don't have the value. So what we're going to do instead is we take that pandas data frame training, look only at the column age, and drop all the NA cells. NA is just missing value. Right? So what I'm left with is all the age values without the ones where there's nothing inside. And I've only picked that single column here. Next thing, we're just calculating the average, and we can use for that the numpy.average function. Luckily, and this is really handy now, there's even a function that says fill NA, and I can put any value there, right? If you wanted to put 1,000 there, you can do that. I wouldn't recommend it because it might bias your model later, but it would be very visible that this is not a true age, because we want to use this as part of a model, and we want to bias the model on the age estimation as little as possible. We're going to use the average age. This is still not completely optimal because we would still introduce certain biases, mostly because we're not capturing the variation that would naturally be here in that age. We have only static values that we fill in. But at least we're not moving the average of the age around. So we're going to use the fill NA function using the average age value that we had stored in this average age variable here. And we're using this on the age column of training. And remember, it's important to also say I'm overwriting the column that was here before with this transformation that I did on the same column. Now if we check the data with this new format, and I'm looking here at the first 0 to 5 values, same as here, we see that missing value has been replaced with 35, which we now know was the average age. Now for alternative ways you could handle NAs or missing values, you can also drop the entire column. We've seen that. We had actually used that during the calculation of the average with the drop NA method. If you wanted to do that on the entire matrix X, you would also lose the information that's contained in other columns here, right? So that other information from the passenger here would be lost. It is a method that if you don't have many NAs, not many missing values here, and you have a fairly large sample size, you can do it. The advantage is it would not bias your data typically. The golden standard in handling missing data is to use some sort of simulation to create a distribution for the entire column of data. So we're essentially modeling the entire age column, and then every time there is a missing value, we're trying to create the most likely value for that missing cell. The typical way to do it is via a Bayesian type simulation. Right? That is fairly complex. So we're going to stick to the method that tends to work in real world setting, which is just put the average value in. But if you have very limited data, that is a very, very good way of doing it. But it certainly adds a bit of complexity to handling that.